Okay, today what we want to talk about is we're finally moving on to Unit 5, the last unit of the school year. Yay! And what we're going to be talking about now is probability, statistics and probability. Well, the first thing we're going to start with is probability, and probability deals with the chances of things actually occurring. We're going to be talking about here theoretical versus experimental, okay? So how many sides are there on a coin? And we should say that there's two sides on a coin, and one side of a coin has heads, and the other side has tails. So if you toss a coin, all right, the probability of heads is going to be 1 out of 2. Okay, 1 out of 2 chances. All right, there's one side that has heads, and there's 2 sides, so that's why we say 1 out of 2, which equals 0.5, which equals 50%. So if we toss a coin, the probability of tails is the same thing. 1 out of 2, 0.5, 50%. Okay, this is what we know. This is what we understand. That's, that's logical. That's what our theoretical says. Theoretically, we're going to get, when we toss a coin, we're going to get 1 out of 2 chances. But now what we want to do is an experiment, okay? An experiment it's going to show us what it actually is, okay? So it says toss a coin 10 times. All right, so that's what I'm going to do. I'm going to toss this coin down here on the screen 10 times, all right? So first time, let's see here. First time, let's get rid of you, I guess. I get heads. I'm just going to go ahead and put a mark here. All right, second time, I get tails. Next time, heads. Next time, heads. Next time, heads. Next time, heads. Next time, tails. Next time, heads. Next time, heads. Next time, heads. I think that's 10. Okay. All right, so we know theoretically I should have had, tossing a coin 10 times, I should have had it come up as heads coming up 5 out of 10 times and tails coming up 5 out of 10 times. But that's not what actually happened here. So the experimental probability of getting heads, experimental, it's based upon my data. You do experiments in science, okay? And we need to record our data based upon the experiment that we did. So experimental probability of getting heads is 8 out of 10, which we can reduce that down, and that's going to reduce down to 4 out of 5, which is 0.8, which is 80%. The experimental probability of getting tails is 2 out of 10, which is 1 out of 5, which is 0.2, which is 20%. Now, you could explain this away all day saying, well, it was because it was on the computer, or maybe because you hit start and stop too quick, but that's not the point here. The point is that our experiment, when we only did it 10 times, when we only did an experiment 10 times, that our probability, our experimental probability, isn't anywhere close to our theoretical probability. So let's go ahead, let's talk about a number cube. How many sides are there on a number cube? All right, if you think about it, there's 6 sides. Each side is labeled differently. I'm going to go ahead and use numbers instead of the dots, but they are 1, 2, 3, 4, 5, and 6. All right, so the probability of getting a 1 would be 1 out of 6, which I need to use my calculator. 1 divided by 6 is 0.1 with 6 repeating, which I'm going to round that up to 17%. Probability of 2 is 1 out of 6. 0.16 repeating, 17%. Again, I'm rounding. Probability of 4, I guess I should be going side to side, is 0.16 repeating, 17%. Probability of 2, oh, I messed up. I apologize. I saw the 4 and I used that number. It should be 1 out of 6. Excuse me. Probability of 2 is 1 out of 6. 0.16 repeating, 17%. 1 out of 6, 0.16 repeating, 17%. 1 out of 6, 0.16 repeating. The 6 is only repeating if you check me on your calculator, and 17%. Okay, so that means that there's a 17% chance that I should get each number when I roll it. So it's saying to roll a number cube 10 times and record my results. All right, so I'm going to roll it 1 time. And I got a 1, so I'm going to record that 1. Roll it again. I got a 3, record the 3. Roll it again. Got a 4. Roll it again. I got a 2. Roll it again. Got a 6. Roll it again. I got a 6. Roll it again. I got a 5. Roll it again. I got a 3. Roll it again. I got a 4. Let's see here. 2, 4, 6, 8, 9. I have one more roll, and I get a 6. Okay, so let's go ahead and look at this data. So, theoretically, I should have gotten 17% every single time. All right, let's see what happened in our actual experiment. So for 1, I got 1 out of 10. Out of 10 times, I rolled it. So that would be 0.1, which would be 10%. For 2, I got that 1 out of 10 times. So that was, again, a 0.1, which was another 10%. For 3, I got that 2 out of 10 times, which was a 0.2, which was 20%. 2/10 should be reduced to 1/5. For 4, 2 out of 10, which reduces to 1 out of 5, which was a 0.2, 20%. For, look, I'm messing up here. I'm going down instead of side to side. I apologize. Probability of 2 was 1 out of 10, which was 0.1, 10%. Probability 3 was 2 out of 10, 1/5, 0.2, 20%. All right, here's my numbers that are wrong. 1, 2, this should be a 3. This should be a 4. This should be a 5. This should be a 6. All right, now I'm seeing why I'm making mistakes here. Okay, probability of 4 is 2 out of 10, which equals 1/5, which is 0.2, 20%. Probability of 5 is 1 out of 10. 0.1, which is a 10%. And then the probability of 6, I got 3 out of 10. And so it's going to be a 0.3 or a 30%. All right, so did my experiment match my theoretical? Did the experiment that I did, all right, the actual data, did it match what it says theoretically should happen? Okay, mathematically, I'm looking at this, and I should have gotten 17% every single time. But when I actually did my experiment, that's not what happened. So this is what I'd like you to do on the back of your notes. On the back of your notes, what I want you to do is to describe the difference between experimental and theoretical probability. Now let me make sure you understand. At this point, no answer is wrong, okay? What I want to see, though, is an answer. What do you think the difference is between experimental, that was our experiment, theoretical is what we know should actually happen. Tell me what you think the difference is between the two. Thank you. Thank you.